For example 12, we see that dy dx is equal to 2xy, and our initial condition is that when x is 0, y is 3. So let's start solving this differential equation as well. Step 1, separate the variables. Like last time, we're going to divide that y term over to the left side, and we're going to multiply the dx term over to the right side. Right? So in doing so, wrong color, let's try this again. We're going to divide by y, so that means we're going to have dy over y, and on the other side, the 2x stays and the dx moves with it. Sometimes students ask, well, should the 2 go with the y? And ultimately, the best advice I can give you is you want to move as few terms over to the left side as possible. The less that's over on the y side, the easier that antiderivative becomes. And usually it's the y antiderivative which is the challenging one. The x antiderivative tends not to be all that bad. All right? And that's the case here as well, because we antiderive both sides. All right, we see antiderivative, and we just have the antiderivative of 2x. All right, that's not that bad. All right, dy over y, still actually not that bad, but a little more challenging. We obviously learned how to antiderive this before we learned how to antiderive that. But you may remember that anytime you have dy over y or dx over x or 1 over x dx, however you choose to write it, that antiderivative will be the natural log. And that's our situation right here. The antiderivative of dy over y is going to be the natural log of the absolute value of y. And then over on the right side, we know that 2x antiderives to x squared. Right? So there's our two antiderivatives. ln absolute value of y is equal to x squared. Step 2 is done. Step 3 we can finish as well just by placing a plus c after the x squared. All right, so now let's figure out what c is equal to. We know that when we plug in 0 for x, we should plug in 3 for y. All right, so we have the natural log of 3, and we don't need the absolute value symbols because we know that 3 is positive, is equal to 0 plus c. So c is the natural log of 3. All right, so now that we have that, we're good to go here. We have natural log of the absolute value of y is equal to x squared plus the natural log of 3. Okay. We got to get y all by itself. So we're going to rely on our pre-calculus in dealing with how do we get rid of a natural log when we're trying to solve an equation. Right? Yeah, we have to use the inverse of natural log, and the inverse of natural log is better known as the natural number e. Yes, so we are going to, let's say we're going to e both sides, all right? So we're going to raise both sides up into the exponent of e, all right? And in doing so, now we have e in the natural log, and they're going to, because the inverse functions are going to eliminate each other, and the absolute value of y comes down to the base level. And it's equal to e to the x squared plus the natural log of 3. Okay. And if we think about this for a second, e is always positive, isn't it? So therefore, we don't need the absolute value signs as far as the y is concerned. Right? Those aren't necessary anymore because e is always positive. So there's no reason for us to think that y could be negative in any matter. And we can leave our answer like that as e to the x squared plus the natural log of 3. Just want you to also be aware of, based off that previous video, that we know that this is equal to e to the x squared times e to the natural log of 3. And e to the natural log of 3 can behave just like e to the natural log of y. The e and the natural log are going to wipe each other out, and the 3 is going to come down to the base level. So another way of looking at this solution would be 3e to the x squared.